Year 12s, welcome to your Replacement Wednesday lesson. Today we're going to find local maxes and mins. The way it's going to work is I'm going to go through some notes and an example, and then I'm going to go through most of the questions from 3C. I'll write them up on the board, and you just fast forward through the video to where you need the help, basically. This will take me a while, and I'm doing it in one shot, so if I mess up, well, that's just going to have to be the way it is. Alright, what we're aiming for is to find where a function turns. And to do this, we generate a sign diagram for the first derivative. A bit like what we were doing with increasing and decreasing functions. This is our sign diagram for x for the first derivative. This indicates that it's increasing until some point, and then it decreases. And what we have here is called a local max. Now, the coordinates of that maximum are f of a. A classic example where students lose marks is they sub in the a to the derivative, and they find out it's equal to 0, and they tell you the turning point's a0. Sometimes they do make it turn at a0, but you don't determine that using the first derivative, you only determine it using the original function. Similarly here, function is decreasing, it is flat, we call it a stationary point, it increases, this is a local minimum. Other things can appear in our sign diagram. We can have positive, flat, positive. This is called a stationary inflection point. We'll consider more of that in the next part of the topic, but it's not a max or min. Similarly here, negative, flat, negative, not a max or min. That is fundamentally what you're looking for when drawing a sign diagram, is where it equals 0 and then the signs either side of those points. So our example, to start us off, is going to be this. Find the max or min, max and min, for this function. Now, the wording here is important. I'm just going to check the camera's actually got that on screen. We're good. The wording here is important. There is a difference between local max and global max. That is a local maximum. But if we just consider the function between here and here, this here would be the global maximum. So just because you found somewhere where it turns in a sign diagram, that doesn't mean it's the highest point in the function. You also have to check the extremes of the domain. In this case, here and here. So in this particular question, they haven't specified local max, they just asked for max and min. If we're asking max and min, then you need to assume that there might be a global max that is not the same as the local max. It's just a little trap. Normally the questions are worded in such a way that you're definitely just finding a local, or it's clear that there's only one max and there won't be a local max competing with a global max. But anyway, let's go through this one. So this says, find the max or min for this. Alright, well first off we need to differentiate. So we're looking for f dash x equals minus 3x squared minus 8x plus 3. Then we're setting that to be 0. 0 equals minus 3x squared minus 8x plus 3. Pen's useless. Now, that missed. You need to find some sort of way to factorize this or use quadratic formula. If you're not sure about factorizing, then just go straight for quadratic formula. Here I can't remember if I set myself at the one that it is factorizable, so I'll use quadratic formula. Minus b plus or minus square root of b squared. Take 4ac on 2a. (64) plus 4 lots of 9, 64 plus 36. That's got to be 100, right? On minus 6. X is either 8 plus 10, so 18 on minus 6 is minus 3. 8 minus 10 is minus 2. Minus 2 on minus 6 is positive 1/3. If I'm wrong, we'll find out in a second. This then gives us our crucial points on the sign diagram. So our sign diagram goes between -4 and 1 and ends there. So be clear that you're ending here. You could easily lose a mark if you did arrows off either side. The default is to do arrows, but that's not actually what's happening here because we've been given a restricted domain. The points we're looking at are -3 and 1/3. We don't really care about scale, as you can see. Alright, so we're aiming to put something in here. -4 is technically in the domain, so we can sub -4 in. If we put -4 in here, into the derivative, that would be -3 lots of -4 squared, -8 lots of -4, plus 3. Bear in mind, you'll have a calculator, so just use your calculator. Now, is that going to be positive or negative? That is -3 lots of 16 plus 4 lots of 8, which is like 2 lots of 16. I think it's going to come out as negative. Then in here is 0. If we put 0 in there, that's nice. It comes out as positive. Here, we can check it, but I would put in a half, or actually put in 1. If we put in 1, it's -3, -8, plus 3, it's negative. So, what that is implying, and you wouldn't necessarily draw this, is that it is going down, going up, going up, going down. This is a minimum, this is a maximum.